Okay, problem 8.15. Suppose we have a random sample of size n that is selected from a finite population, uh, which are just a bunch of numbers, so 1 through capital N. So we're going to select n of them uh, in order without replacement. And one question is to show that the sample mean has expectation equal to this, sample variance has the expectation of this, and if y equals to n times the sample mean, then the expectation of y is this, and the variance of y is this. So actually the last one is just super trivial, right? Because we know that if y is simply just the n scaling of the x bar, then the expectation of y is just n times the expectation of x bar. The variance of y is just n squared times the variance of x bar. And we already know the mean and the variance from the first two things. So actually the C is just something trivial. Okay, so the key is to show A and B. For A, we need to show that, remember that for the random sample from a finite population in order without replacement, the expectation of the sample mean is just the expectation of every one in this random sample. So let's say the rth one, XR denotes the rth selection. Expectation of XR we denote by mu because we know that this is actually just, it doesn't matter what R is, it's always taking the same value. And the formula for that is just the average of the values of those terms in the population. So remember that the CI is the ith term in the population, but the population is just a bunch of numbers, which is 1 through n. So the CI is just the I, the number I. So you take the average of those, it's just 1 over n times the sum of the CIs, and the CI is just equal to I. So the sum of the I's is equal to, this guy here is just equal to that. Right? And here you have the 1 over n again, just copy down below. And then you just make the product of these two guys. You can see that n cancel. So you just have half of n minus n plus 1. That is the expectation of every one of this, and also the expectation of the sample mean. So that's how we get the part A. For the part B, we know that the variance of the sample mean is equal to sigma square over, let me just show you the formula. We know that this, right? This is what we learned in class. So this sigma square is actually the variance of the xi. I don't need to specify which xi. Again, xi is xr, the capital R, xr. This is the rth selection in the random sample. Every one of them has the same marginal distribution, and so they all have the same mean variance. So the sigma square is actually the variance of this, and then the variance of the sample mean is just the variance of each of these guys, which is sigma square here, divided by n and multiplied by, scaled by this number. Okay, so remember this is the key difference from the variance of the sample mean in infinite population, in which case the variance of the sample mean is just this guy. But if it's a finite sample, we're going to select things without replacement, then the variance is actually this. It's a scale like this. Okay, so now the key is just to figure out what this number is, the variance of the R selection. So to compute that, you call that the distribution, or the PMF for the XR is just 1 over n, right? This is what we learned in class. And also we want to calculate, we already calculated the mean. The mean of these guys is just equal to half of n plus 1. And now we just need to calculate the second moment of XR. And then we can use this to get the variance of XR. So the second moment of XR is just the weighted average of XR squared. So the XR can take a value CI, so that will give us the CI square. But remember, CI is just I itself, and you just have this 1 over n out here, and you take the sum of the I square. So I square, sum of I squares from 1 to capital N is this part. So we know that formula. So you have a 1 squared plus 2 squared plus all the way to m squared. You actually have this equal to m times m plus 1 times 2m plus 1 divided by 6 for any integer m. Okay? So that is the variance, or sorry, the second moment, which is this guy. So the variance is just the second moment minus the square of the first moment. The second moment is something I just copied down. And the first moment is something we computed here, and we need to square it. So now I just need to calculate the difference of these two. So after some calculation, you realize that you reach to this guy. So this is actually the variance of the XR, okay, the R selection. Actually, this is the variance for every selection. Doesn't matter what R is. The R could be from 1 to 2 to little n. Okay, so they all have the same variance. This is something we showed in class because they all have the same marginal distribution. Okay, so now with this, we know that by using the formula we learned in class, the variance of the sample mean is just this guy where the sigma square is copied down. Okay, so we just copy it down here, and then we just do some simplifications, we get this guy. So that is the variance of the sample mean. And as I said earlier, the C, part C is kind of trivial, just calculate the expectation of and the variance of the Y, which is just simply scaling the some scaling of the X bar. So we just get the mean and variance for the Y.